This is the last video in 4.4, which is 3.4 in the 6th edition. We're going to kind of put together this other stuff that we've done in 4.4. So we'll start by looking at this polynomial and seeing what we can find out about it. Okay? So first of all, let's just look at the Descartes' rule of signs. You notice that there's a change right here and a change right here. So it starts positive, positive, negative. So there's one change, negative, positive. So there's two changes. Okay, so there are 2 or 0 positive zeros. Okay, and then if we look at putting negative x in, this one would stay positive because it's an even power. This one would change. It would change to negative. This one would stay negative. This would change, so it would be positive, and this would stay positive. So there's 1, 2. So there are 2 or 0 negative zeros, which isn't really all that helpful in this case. Alright, so now let's look at the possible zeros. The rational zeros. Okay, so the possible rational zeros. Let me get rid of this. Make a little bit more room here. So you notice that this one is an 8 and this one is a 1. So we'll just be looking at factors of 8 over 1, so just factors of 8. So we have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Okay, so those are the ones that we'll try as we go along. We'll find out if we can use the upper bound or lower bound theorem. So let's just start with the positives and see what we find. 1, 6, negative 9, negative 6, 8. And we'll start with 1. 1 times 1 is 1, that'd be 7. 1 times 7, that'd be negative 2. Negative 2, that'd be negative 8. Negative 8, 0. Alright, so we found our first 0. So our first one is 1. That means factored, I've got x minus 1. And what's left is, I can read it off of this answer here, right? X cubed plus 7x squared minus 2x minus 8. Okay. Alright, so I found one. Oh, darn it. Yeah, alright. That's okay. Now we're going to work with just the new one, right? Okay, so now we're working with this. I don't need to do it into the big equation anymore. I'll never get anywhere. Now I'm working with a cubed equation. So every time I find a 0, it gets to be a smaller equation that I'm working with. Okay, now we should probably try 1 again because there could be 2 of them, right? It could have a multiplicity of 2. So 1 times 1 is 1, that's 8, that's 8, that's 6, and that's 6, and that's negative 2. So 1 does not work. Again, we have 1, it has multiplicity of 1, right? Let's try Let's try 2. 2, 9, 18, 16, 32, 24. Ah, well, what do you notice about this? Okay, this is all positive. Every number is positive. So that means that 2 is an upper bound. Okay, so I don't have to try positive 4. I don't have to try positive 8. I just have to try maybe the negative ones, but not the positive ones. Okay? Alright, so we've tried all the positives. So what do you think that means that I said here that it was either 2 or 0? It was either 2 or 0 positive zeros, right? Well, I found 1. So where's the other one? I know there's got to be 2 because there's not 0, so it's got to be 2. Well, we've tried all the rational positive zeros, or at least we've eliminated them, right? So the other positive 0 must be irrational, and which means we must have some irrational zeros. So we'll get to those. In the meantime, let's see if we can find a negative one. Okay, so let's try negative 1. Negative 1, that'd be 6. Negative 6, negative 8. Oh, look, negative 1 times 8, that's positive 8. That's a 0. Okay, so negative 1 is a 0. And it also means that instead of this factor, I know that it's an x plus 1 from right here, right? And then from here, I know that it is x squared plus 6x minus 8. Now, can I factor that? Well, I'd have to have two things that multiply to be negative 8. So they'd have to have opposite signs. And it's either going to be 1 and 8 or 2 and 4, right? But they have to add up to 6. Well, these would add up to 6 if they're the same sign, but they're not. Okay, so there's no way for me to get this. So this is irreducible. So this is how we would factor, unless it says to completely factor to linear factors, and then I would go ahead and write this, and I'll show you how we'll write that in just a minute. Okay, so now what I know is, let me give myself a little bit more room here. What I know is this quadratic. Okay, this quadratic, if I solve this for 0, I'd have negative b, so that would be negative 6 plus or minus the square root of b squared, that's 36, minus 4 times a times c over 2a. Alright, so that is, let's look in the inside here. 8 times 4 is 32, and they're both negative, so that makes it positive 32 plus 36. So that's going to be 68. And 68 can factor. If I have 68, I know that 2 goes into it 34 times. And 2 goes into that 17 times. Alright, so I have 2's that will come out. 17 stays under. And I can take a 2 out of everything, so I've got negative 3 plus or minus the square root of 17. Alright, those are my zeros. They're irrational, right? But they're my zeros. So I've got negative 3 plus square root of 17 and negative 3 minus square root of 17. Okay, so I wanted all my zeros. I found all my zeros. Okay, now look. we have 1 is positive, and square root of 17 is bigger than 3. It's like bigger than 4. So this is a positive number. So I have 2 positives. Just like I said I would, 2 positives, right? And -1 is negative, and -3 minus and more, minus negative, more negative, that's negative. So I have 2 or 0 negative zeros. Okay, so that is where it fits in with Descartes' rule of signs. So if I were going to write this completely factored, I have these 2 factors, right? And it's always going to be x minus the 0. So x minus -3, so that'd be +3 minus square root of 17. And x minus -3, so that'd be +3 plus square root of 17. Okay, that would be it completely factored. So just to review again what we're doing, we get the information we have on how many positives, how many negatives. It didn't tell us a whole lot of information. It would really be useful if you knew for sure there was exactly 1, or if you knew for sure there were none. That's when it's most useful. We find out our possible rational zeros. We start trying them using using what we learned from Descartes' rule of signs and using upper and lower bounds. We start narrowing it down until we find some zeros. We find enough zeros that what's left over here is a quadratic. Once we have it to a quadratic, we can either factor it or put it into the quadratic formula and find the other 2 zeros. That's what we're after when we do it. Okay, so here's your quiz question. You're going to do the very same thing. I've given you an equation. Go ahead and find all the possible rational zeros and start trying those rational zeros until you find 1. Since this is a cube, as soon as you find 1, you'll be down to a quadratic. Then you can take the quadratic and you can just factor it or plug it into the quadratic formula to get the other 2. I want you to find the zeros. There should be 3 of them. And then go to Canvas and list those in the quiz question for 4.4D. And that would be the second question.